Will AI solve climate change or make it worse? Predictions are flying around, but here at Proof News, we're actually interested in the facts on the ground right now. I'm Julia Angwin, founder of Proof News. Welcome to our Proof Ingredients video series where we talk to people who have proved things about how they did it. In this segment, we're so lucky to have Sasha Luccioni here to inform us. Amidst all of the hype and doomsday scenarios about AI that are swirling around, Sasha has actually done the hard work of analyzing the actual true, on the ground, this moment climate costs of AI models that are up and running right now. Her numbers are the most solid information we have since the companies that make AI aren't telling us that much. Sasha has a PhD in artificial intelligence and is currently the climate lead for a tech company called Huggingface that hosts thousands of AI models and apps with the public. Sasha, thank you so much for joining us to talk about your groundbreaking work.
Thank you for having me. It's such an honor.
It's great to have you here. Maybe you can tell us your background, how you got into artificial intelligence. You were probably thinking ahead.
Yeah, it's actually really funny. I kind of drifted towards AI. I started out in linguistics because I really like languages. And then I did cognitive science because I wanted to understand how people learn language and how they think. And then finally, I kind of picked up some programming and I did an internship and I was like, hey, this programming thing has its benefits. Like the fact is that you can really kind of create something. It's kind of a very powerful way of interacting with the world. And so essentially for my PhD, I decided to go into artificial intelligence and I worked in my thesis actually was on education and how to help people learn languages using AI. And then when the real world happened after that, I started doing more applied research. And then after a couple of years working in applied research, I had what I call a quarter life crisis when I was like, what am I doing with my life? And then I was like, I'm going to quit my job. I'm going to go plant trees. I'm going to, I don't know, whatever, live off the grid. And then my partner was like, well, maybe you can use this like 10 years of studies that you did to do some good, some like environmentally positive work. And that's how I started working in AI and climate change. And we actually created a community, the climate change AI community that didn't exist before. And I've been working in this space for like 6 years now.
Yeah, you come from a long line of women scientists. Is that right? Can you tell me
Yeah,
about your
exactly.
background?
My great grandmother, she was a researcher and in geology, and then my great grandmother, a chemist, and my mother has a PhD in statistics.
So let's talk about your investigation that I was referring to. Right, there's so much out there that it's attempting to predict what will happen with AI, right? Like, will it solve climate change? There's a whole bunch of people who say, oh, it's going to like magically, figure out ways for us to solve it. And then there's all the people saying, oh, it's going to make things so much worse and all these projections. But the projections have to be based on something. And that something is sort of unknown because the companies aren't telling us sort of basically a lot of details about how much electricity AI uses. So tell me what you were looking into investigating and how you came up with the question you were looking into.
Like 3 years ago when I joined Hugging Face, it was in the scope of the Big Science Project, and it brought together like 1,000 researchers and AI practitioners and like legal scholars from all over the world, essentially, to train the first open source large language model, so called Bloom. And I was in charge of the carbon footprint estimation work, and we did some really cool stuff because we actually had access to the training logs, and we could go into like really the granular details of like energy usage and carbon emissions and stuff like that. And then as part of that study, we essentially deployed the model. We put it up in like on a cloud compute server, and then people were querying it kind of organically. People were just interacting with it. And we also measured the energy usage and estimated carbon emissions based on where that energy was coming from. And that was really interesting because we found that depending on the number of requests we got, obviously the energy consumption varied, but also that there was always an amount of energy that was dedicated to keeping the model in memory. So even if no one was actually interacting with it, it still used energy. And so that was kind of like the first inkling for me in terms of like, let's look at deployment, because all of the previous carbon footprint estimation work and energy estimation work was really focused on the model training because it's kind of a little bit more I guess I want to say well-defined. Like you press a button and then the model training starts, and then you press stop, and then you can really like calculate quite precisely how much energy was used and how many like tons or kilograms or whatever of carbon emissions were emitted. But for deployment, it's a lot more like people kept telling me that it's just impossible to estimate because it's almost like it's almost intangible. Like there's all these different instances of models running in all these different places, and so every time I would ask a tech company like, oh, like how much energy is this AI tool using, they'll always be like, oh, well, it's complicated, we don't have the numbers. And so that's how we decided to do our study on AI model deployment.
And so, what was your hypothesis going in? Were you testing basically how much uh, electricity is used per query, or like what was the exact question that you were looking at?
It was kind of a broad question of like, how do we understand the energy usage of deploying AI models, and how does it vary? Like essentially we defined 10 different tasks, because when I started like kind of playing around with models just off the Huggingface website, that like it's open source models that people share, and then I realized that there's like all these different ways in which models are used. So I was like, well, maybe it doesn't really make sense to compare like text generation models with image generation models, because they're kind of different, doing different things. And so we started thinking about how to make categories and how to like test the energy consumption of different models. And essentially the idea was like, can we figure out what impacts this energy consumption? Is it going to be the size of the models? Is it going to be the task that they're used for? Is it going to be whether they're generative models or discriminative models that are like limited to a set number of categories? Like what are these different criteria, and can we actually measure them?
And so then how did you measure them?
So we defined these 10 different tasks. So like everything from text classification, image classification, summarization, question answering. And essentially for each of these tasks, we took popular data sets that people use for evaluating these tasks, models on these tasks. And we used the same data set across as many models as we could get our hands on. So I think over 100 models in total, and we compared how much energy was used. And the idea was like, if you use the same hardware, if you use the same data set, if you really have all of the, like if you make sure that you keep all the variables stable, and then you only have the model that's different, can you really measure the energy? Like what differs in terms of energy consumption? And we did find that, for example, one of the biggest things that, most surprising things for me that we found was that if you have the same task, like answering a question, and on one hand you have a model that's only doing that task, and like it's called extractive question answering. So essentially like you have a text and you're like, what year was Napoleon born? And it's going to find in this like Wikipedia entry the year of birth of Napoleon. And on the other hand, you have a generative model and you asked it, what year was Napoleon born? And it's essentially generating the answer to your question. It's not really extracting it from any like set document. It's actually, inventing it, quote unquote, from its training data. And just that like was a 20 to 30 fold difference in terms of energy usage, just for the same like types of questions, like for the same questions essentially.
So 20 to 30 times more for the generative
Yeah, exactly.
AI.
The generative models, like depending on the size, of course, there were factors that that influenced it, but like typically like generative models use orders of magnitude more energy for various reasons. On the one hand, it's like really that the task is actually different, because you're not like extracting existing information, you're like generating new information. But also most generative models in this day and age are supposed to be like multitask. They're supposed to be able to do multiple things at once. So like both, giving you recipes and answering questions and writing poems and captioning images and like all these different kind of subtasks. And so they're typically bigger and they need more training data. And like, I think that also is part of the issue, is that we have these like general purpose, quote unquote, models that are just inefficient compared to single task models.
So how much energy are we talking about, right? Like when I do a query like that, is it like the same as turning on my lights in my room or leaving a tea kettle running? Like, is there a way to say what the electricity usage is per query, or is that too small a unit?
Um, no, it's not, but we don't have the information.
I see.
Essentially, people tried to estimate it, but Google hasn't released, Google or whoever hasn't released the information. So we don't know. What they say is kind of like, well, depending on where you're located in the world, the actual model or the actual like algorithm that's serving your results can be at a different place. So it's hard to estimate exactly how much energy is being used. But yeah, essentially we don't have these numbers. It's not that much. The estimate that I've seen was like 0.3 watt hours of energy. But once again, this is like an estimate that someone did. But the thing is like how many Google queries are done every day, right? Like how fast does that add up?
Right. And then by comparison, when you do something like that with one of the Gen AI models that you tested,
It would be
is
like
there
3 watt hours of energy. So like around I mean, according to people's estimates, it's around 10 times more, but depending on like, if you take like the smallest extractive question answering model and the biggest generative model, the difference is like 20 to 30 times more energy.
Got it, got it, got it. Okay. And so if it's 3 watt hours for one of these for a generative AI model to do a query, uh, what does that look like in my real life? Like, what do I do that I'm not used to thinking of my daily life in terms of watt hours.
So something like maybe charging a smartphone, not for the Google query, but for like image generation, generating like a high quality image using like one of the bigger image generation models is essentially equivalent of like half of a smartphone charge, just to give you an example of orders of magnitude. So it's actually pretty significant. Whereas, I mean, for text generation, it would be a lot less because instead of generating like pixels on an image, you're generating words, tokens. So it's a lot less.
So your study, you looked at 100 models and you got these estimates for all of their tasks. And so overall, what was your conclusion about sort of the electricity usage? Was it higher than you expected?
It is really variable. I was actually pretty struck by the range. Like the most efficient task is text classification. So something that's done a lot, for example, is trying to classify like either movie reviews or product reviews as being like positive or negative. And so that's like the most efficient task. And then compared to like, if you compare image generation to that, it's like thousands of times more energy because I mean, if you think about it, on one hand, say you have like positive, negative, you have essentially like 0 and 1 are the only two possible options for classifying a product review, for example. Whereas when you're generating an image, you have like the pixel space, like however big that is. And for each pixel, you have all of the choices of colors, right? Which could be 256, or sometimes it's like thousands of color choices. And so essentially, like the number of possibilities is a lot bigger when you're generating an image versus just classifying a text. So it was like a huge range. It was like even when we did the plot, we had to do the vertical axis, the y-axis in like logarithmic scale, just because like otherwise like the difference was so big that it didn't really fit.
So that implies that like a lot of these models are just, it's really variable, right? So for instance, if I'm using Meta's Llama, it might be one thing. And if I'm using OpenAI, it might be another thing. And if I understand correctly, you actually couldn't test a lot of the closed source models,
I
right?
couldn't test
So
any of the
these,
closed source models. These are all open sourced ones. Like essentially Huggingface, the company I work at, is like a platform for sharing AI models. And a lot of big tech companies share like Llama, the models are there, and like Microsoft shares their models. But for example, if you're using like Google and they're doing some generative AI summary, like that model won't be on Hugging Face because that's like a proprietary model. Same thing for like ChatGPT. Like there's some older versions of the GPT models on the Hugging Face hub, but like the actual ones, like the GPT 4.0 or whatever, whichever one is isn't the one being used now, is not available. So I can't test it. And it's really frustrating because I got a lot of pushback being like, well, how about actual like real live products, real live tools? Like what you studied is not what people use in real life. And you're like, yeah, but I can't I can't access those models. I can't test those models.
right. And the companies also, they actually could tell you without even running a test, they could just tell you how much
Exactly.
electricity is being used, right? But they do not.
They do not. Yeah. No, and also like there's just this like weird dynamic because like the companies that provide like a lot of the AI compute and like the solutions and stuff like that are actually the ones making the products. I mean, there's a bit of a conflict of interest, let's say. For example, like you could, use Microsoft Copilot, or you could also like host your own AI model on one of their like Azure compute instances or whatever, and it's like the same company. So I feel that like they just really don't have any incentive to give you this information because it's like
Because they control all the parts of the supply chain, basically, right?
exactly,
So it's
yeah,
like
yeah.
it's Microsoft all the way down. Right.
Exactly, yeah, yeah, and also they have this incentive to sell you more products. They put so much money into this. They build out these huge data centers that use all this energy, and now they need people to use these data centers.
Right. But it is kind of crazy because I think we do have some inkling that this is causing a lot of energy use at these companies to skyrocket, right? Because we've seen the latest. what do they call them? The sustainability
G
reports that the
reports.
companies
Yeah.
publish. And they don't necessarily say that it's because of AI, right? But it does look like their energy use is really exponentially increasing.
Yeah, like Microsoft and Google recently published their reports, and essentially, I think Microsoft, the number was like 30%. Like their energy use went up 30% within the last year, and they don't say it was. I mean, they say it's partially due to AI. It's not 100% due to AI. But what's interesting is like essentially they're saying, well, our like climate targets or like our whatever net zero ambitions were so ambitious that like we didn't expect AI to have such an impact on them. Essentially, like they're even themselves surprised because most of these targets were made before generative AI was a thing. So you have that on one hand, like the numbers are there, but on the other hand, a lot of people from these companies are keep saying that the problem is just going to solve itself. Essentially, like yeah, of course we're seeing this spike now, but either AI is going to help solve climate change, or like the efficiency is going to go up so much that it's not going to be an issue anymore, or we're going to have some magical energy solution that's going to magically be invented in the next year or so. Like I mean, essentially, like on the one hand you do have the numbers, on the other hand you have this like corporate messaging, which is just like nothing to see here. Why are we even talking about this?
I find those so interesting because it appears that there's no evidence for it, right? They're just like, it's magical thinking. They're like, oh, AI is going to solve climate change. And I'm like, well, just show me one little shred of anything that would lead me to believe that that's true. I mean, am I missing something? But I just I don't understand those claims.
So for me, they're two separate conversations. So AI can be a tool. So the thing is, climate change is not like a single problem, and that's kind of the issue, right? There's a lot of different things to be solved, and it's true that AI can be a part of the puzzle in a lot of those things. Like for example, optimizing energy grids. Actually, like you can use AI to dispatch or to like connect grids in ways that are more optimal and actually save energy. And AI can be used to like detect leaks in energy grids or do predictive maintenance. Like there's all these kind of energy based applications. There's also improved climate modeling. There's also I know there's all sorts of like for example heating and cooling systems as well in buildings, for example, that are like really inefficient. You can save a lot of money and energy by using AI and doing like smart adaptive stuff. So there are like small specific questions that can be solved to some extent, like can be helped to be solved with AI, but it's not like a panacea. Like it's not going to solve everything, right? And the fact like presenting it as we need to be using this much energy because AI is going to solve climate change, for me is just like there's no logical link between these two things.
Yeah. So let's talk about what we know and don't know based on your work, right? So I think you put the first contours around like what the truly like the actual usage of these models, right? But there still remains a lot of unknowns. So tell me what we still don't know and what we need to know.
So essentially, I mean, the unknowns about proprietary models in general, like each ChatGPT query or each Google search, I think we really need to know those numbers. And like even so, there's like the per query numbers, but there's also like how many copies of these models are running, because like that ChatGPT is not going to be like a single, like it's not going to be one model. It's probably like thousands of them or tens of thousands of them, given like the 10 million users they have every day. You need to have like X number of models in order to reply. So we need like also like the atomic number, but also like the cumulative number. In the big science project, when we were doing the carbon footprint estimation, what I realized is that we were always looking at just like the energy usage, but there's also like the life cycle. And then what we proposed in that paper is that like maybe we should look at the AI life cycle, because for example, if you buy a tote bag or a pair of jeans, like you can look it up and there's like a life cycle analysis of the water that was used, the cotton, the transportation, the dye. And I think that we should have similar things for AI, because on the one hand, of course, we have the energy, but we also have the water. We also have the metals that were used for making the hardware. We also have the transportation, and we have all these different pieces of the puzzle that we don't essentially see if we're only looking at energy, for example.
Right. And now aren't you trying to put together some sort of rating for AI on
Yeah,
energy?
so it's still about energy use, but like for example, in terms of a life cycle analysis, I've been trying to get numbers about hardware. So essentially, most AI models are trained on what's called a GPU. So it's like a graphical processing unit, and it's like a type of computer chip that was initially invented for computer games, and because they essentially can do a lot of parallel processing at once, whereas the traditional CPUs were very like sequential. Like you had like one thing running at a time, and then AI needs a lot of parallel compute. So they started using these GPUs. And nowadays, like before, you would use like one GPU or 8 GPUs. Now people are using like 10,000 GPUs essentially. And like you're like the amount of compute needed to train an AI model is now measured in millions of hours of GPU compute. So it's like essentially gotten to this crazy level, and we don't have any numbers about like where these GPUs are coming from and how many natural resources were used to create them. And so essentially, like NVIDIA has become one of the most valuable companies in the world, and we just don't have any of that information either. So people are like, oh, I'm going to go AI first. I'm going to build myself this massive cluster for my company or for my business or whatever, and then they buy like 10,000 NVIDIA GPUs, and then like there's no assessment of like the impact that has on the planet, or how much energy was used to create these GPUs, or rare earth metals mined in terrible conditions in countries that are far away that people don't think about, right? Like, all of these aspects like really blow my mind. So yeah, with regards to the project that I'm working on, it's starting with energy because it's kind of like where we have the most information, and the idea is to develop energy star ratings for AI models, so that when people either are training a model or picking a model to use, or for policymakers, for example, when they get around to legislating these models, to give them an idea of like how a given model measures up compared to other models in the same like category. So, for example, for question answering, like how this given model that you're looking at compares to other models that can do question answering, and the same thing for image generation, same thing for voice speech to text as well. And so like around all these different tasks, the goal is to establish like these ranges of minimum and maximum energy efficiency, and then kind of essentially show how models measure up.
Oh, that's so great. I would love to know that. Because I mean, I feel like this sort of speaks to the fundamental question I have about generative AI, which is like, is it worth it? Right? Like, is it worth all the electricity, water usage, metal usage, etc.? Like, because right now I'm not getting like a huge value out of it. Like, I've tried to like it can't, I'm a writer, so obviously I don't really like it to write for me. But even when I have it do suggestions, it's not great. Now my daughter likes it for programming and finds it helpful. So I do feel like there's some uses, but like overall, I don't know that I could make an informed decision about it because I don't understand what the cost is to the world, right? And so it seems like you would be providing some way to quantify a little bit of that.
Yeah, and I honestly think there's no single answer to that question. I think that it's important to kind of like disentangle the different usages, so we don't keep on, because also like AI is such a broad term that often like people are like, oh, AI, and they mean whatever, chat GPT, and sometimes it's like AI and they mean robots or whatever. And so it's like I think it's important to have all these different categories, and to say, well, for this category here's the range. So actually maybe in the grand scheme of things it's a lot of energy, but given the category it's relatively efficient.
Well, I appreciate your work on quantifying and giving us at least some sense of where we are with how much energy is being used when we use these models. And I'm super excited to see your Energy Star ratings. I feel like it would be really nice if they were competing on transparency, right? And like trying to be the model that was the most transparent. There was a moment I feel like where they were doing that a little bit,
Yeah.
early days, right? But
Mm-hmm.
it feels like that's shifted a moment. But
Yeah, I feel it now because it's become like a product. Like before, it was like AI.
yeah,
Like when I started, it was just like whatever, like a theoretical or like very
yeah, it was
researchy
felt more
thing.
academic-y. Yeah,
Exactly. Before, like people would train models, and then they would write research papers where they said like they gave access to code, they gave all the details, they gave sometimes like the amount of compute that they used and what kind of compute it was. So even if I read the paper, I could be like, oh, I can like estimate the energy usage based on these elements. And then since ChatGPT came out, essentially since November 2022, everyone's cracked down, and essentially now, when especially like a large language model comes out, like the amount of information provided is usually not enough to know neither the energy usage nor where the data is coming from, nor like even sometimes the size of the model isn't divulged. So it's like it's become pretty secretive as a domain.
yeah. I mean, look, we are over here at Proof trying to pry open some of those secrets. We just recently revealed the YouTube data set that was used to
There
train
you go. We need
Claude.
more of that work. Yeah.
Yeah, we're doing what we can. But I hope you get them to release this information because I think it's really important, right? Like at this point, we're all trying to make the best decisions we can about our own behavior and how it impacts the climate. And so if we could have information to make better decisions about the use of AI, that would be awesome.
Exactly, and
Um,
actually, like the EPA, who developed the original Energy Star ratings, like in the 80s or 90s, I think the way they were kind of presenting it was not only like efficiency for climate change sake, but was really like saving users and saving consumers money, and so that's also like a indirect part of the equation.
Thank you for your work making AI more transparent for all of
Thank
us.
you, and I'm looking forward to seeing your study.